I think it would be beneficial for us to talk about these two problems right here. Do these look familiar?
Yes.
Okay, you have 1 minute at your table to determine, maybe like a minute and a half, to determine what these are. You're not taking the limit. It's not going to happen. You can do it without taking the limit. So work together and come up with what these are. Put them away and notes out now.
So the second one is the one I was just talking about. The quiz. I know. I'm so good. So it's x cubed with a plug-in 2 for x. So it would just be the x in seconds.
Oh.
The first one, don't know. Oh wait, no. Wait, no, I got it. It's cosine x, so it's negative sine x.
Yes.
Getting better. Oh, my notebook got water all over it. This is upsetting.
Rain.
Yeah. Right? Right as I got out of my car to go to an NHS meeting, it just dumped buckets
I
on
set
me.
my car to like 8:05 and waited for it to stop and actually.
And you just accepted the fact you're going to be like,
I wasn't really. I knew they were gonna let me in because it was raining.
Yeah.
And I didn't get targeted. It was fine. Just Jansen said you can make one usage word.
all right. Brayden, explain to me this first one.
Well, the function is cos x,
Okay.
so then I just change that to negative sine of x.
Okay. So this means take the derivative of cosine of x. And you took the derivative of cosine of x to get sine of x. Do you agree?
Yes.
Okay. Do you see how it looks like the difference quotient limit?
Yes.
See that? So we know that means derivative. Okay. This second one, Isabel, what does it mean? So this means take the derivative of x cubed and then plug in x is 2. So what's the derivative of x cubed? 3x squared. And when we plug in 3x squared, we get 12. Cool. Okay. You will see problems like this on every single AP test. So while you had that hidden bonus on your quiz, no longer will that be a hidden bonus. That is one that I'm going to expect you to be able to recognize from here on out. Does that make sense? Okay. Okay. Question. What if I asked you to take this derivative? What would you have to do? You're going to have to...
You have to multiply. Could you find the derivative?
No. We only know the power rule, and the power rule only works when we have a ax to the n power. And right now, we have ax to the n power, but they're being multiplied. So much like you did on your quiz, we would have to multiply all of this out, so we were separated by addition and subtraction, and then we can do the power rule however many times that, whatever terms, probably like 7 terms by the time we get it all out. Okay? Does that sound efficient?
No.
Not particularly. Okay? So, do you think that maybe it would help if we had some more strategies than just the power rule? Okay. And that's really what the rest of the chapter is about. What other strategies are there for taking derivatives besides just the power rule? Because it is going to get exhausting if we have to use the power rule for everything. Okay? And there's going to be times when the power rule is not going to help us at all. Okay? So today and tomorrow, we are going to work on the product rule and the quotient rule. So, number 1, this is a product. Here is the product rule. Let's just look at it. Like, don't write anything down quite yet. The derivative of a function times a function, f times g, is the derivative of f times g plus f times the derivative of g. So do you notice how one's a derivative and one stays the same, plus the other one's a derivative and the other one stays the same? Write it down. When can you use the product rule? When you have two functions multiplied. If you have a product, you can use the product rule. Now, I would not use the product on something like 2x squared. Yeah, I know 2 is being multiplied to x squared, but that's not an efficient use of our time. The power rule can help us there. Yes?
Isn't that law the same as the dot plot? Or like similar?
Well, the dot product is in
yeah.
vectors. And we are multiplying similar components of two vectors.
So they're not related?
No, not
Okay.
sorry. This is good talk. That dot. And you're adding two things. Okay. Now, is addition commutative? What does commutative mean?
Switch the order.
Okay. Addition is commutative, so it really doesn't matter which one is f and which one is g, as long as you take the derivative of first times the second plus the first times the derivative of the second, or vice versa. It really doesn't matter which order, as long as you're pairing them up, derivative and function plus derivative and function. Okay? So really, we just need to practice. Go ahead and write down this one if you didn't already. Yes. Oh, high five. Thanks.
So is the entire thing f of x are going to give us another equation? Or is the first parentheses fx and the second parentheses?
So it's a product,
It's messing
right?
me up.
So these two are being multiplied together. So we're going to view this as our f of x, and we're going to view this as our g of x.
Okay.
Mm-hmm.
F of x in front of the entire thing. It confused me.
Okay. Okay, so our product rule, when we go to find our derivative, okay, we are going to take the derivative of the first function. So the derivative of that first function is 3x squared plus 2. And we multiply it by g, so we keep g the same. Plus, then we're going to keep f the same and multiply it by g prime. Okay? So our first function stays the same. And our second function, we are going to take the derivative of. Is there a question? But now you can leave it like this.
Oh. That's our friend.
Yeah, we're done. Now, if we were to have to go forward and set this equal to 0 and solve, you are right, this may not be taking less time, excuse me. If we would have to set this equal to 0, we would need to multiply it all out, okay? But we don't have to, so you can leave it like this, okay? But, and this is something we'll keep talking about throughout the unit, There are going to be times where certain strategies are less efficient than others, but we need to be able to understand how the strategies work before we have to make those decisions. Okay? So, on a test situation, quiz situation, if I gave you this, if you multiplied it out and did the power rule, I would grade it accordingly. If you did this, and I would say just leave it, don't simplify it, that's fine. Okay? During Unit 2, we're going to work on our strategies. And then in Unit 3, when we start to use our derivatives to find something else, then we'll start talking about having to simplify our derivatives. But we're not going to have to worry about that quite yet. Okay? So now you feel a little bit better about the product. Okay? Go ahead and write this one down. Okay? And here again, some of you are going to look at this and think, ooh, I can distribute x squared and use the power rule. Is that wrong? No. Some of you are going to see this and think, sweet, I have a product, I can use the product rule. Is that wrong? No. Okay? So give me a little grace when I'm grading these. Okay? There's going to be different strategies that you can use throughout these problems. You just kind of have to decide which one you think is going to be more efficient. All right? If we use the product rule, okay? Okay? And I don't think you're going to have to write this down every time, but I'm just going to write it down so you can kind of visually see what's going on. All right? Our derivative is going to be, the derivative of the first is what? 3x squared times our second function, x squared. Plus our first function, x cubed plus 1, times the derivative of our second function, okay? Now, I am fine with you leaving it like this. Some of you are going to go the extra step because this bothers you, and you're going to say, okay, well, this is 3x to the fourth plus 2x to the fourth plus 2x cubed. So my derivative is 3x to the fourth plus 4x cubed. Right? Did I do my math right? Nope. I added the wrong ones together, didn't I? I was reading that as a cubed. 5x to the fourth plus 2x cubed.
It's okay.
The hardest part of calculus is algebra.
We've been there.
Right? You've been there? Okay. But if you stop right here, for Unit 2, this is really all I'm expecting of you. Okay? Write it down. Okay. Is this a product? Yes. We have two functions multiplied together. And when we have two functions multiplied together, we need to be able to do the product rule. Okay? So, derivative of the first. So we have 2x sine of x, right? Derivative of the first times the second plus the first times the derivative of the second. So I'm going to keep x squared, and what's the derivative of sine of x? Cosine of x. Not so bad, right? Okay, I'm going to make you get out of your seat for 3 minutes.
Wait,
Yes.
so when we do that, and if we added that together and got like one,
And get what?
so if we simplified that,
There's no way to simplify that.
but like, okay, for the other one,
Okay.
where you got one single polynomial,
Mhm.
is that the derivative, or do you have to do the power rule to get?
No, you've already taken the derivative. By doing the product rule, you've taken the derivative. So all I did over here, I just combined like terms.
Okay.
This is the same as this. They're both the derivative written a different way. Okay? Now, you could have distributed this through, and let's talk about that. If we wrote y equals x to the fifth plus x squared, notice how our derivative matches here. Are you with me? Like if we take the power rule of these guys, we'll get to here. Okay, so take your notebook with you. You'll go back to your seat in about 3 minutes. But I want you to decide, would you rather have a superpower? You'd go to the door corner. Meet the love of your life today. Gather by my desk. Never feel tired. Flag corner. Own a time machine. Couch corner. You have 5 seconds. Go. It's really okay.
Wait, but if you had a time machine, you
Okay,
could
like,
I
I
know.
I would never be tired. I would never.
I could never feel tired. I would never
Alright.
go to bed.
I would become like
Yeah, I would.
Now, focus. Focus. It's very interesting. Oh, this is broken up. Based on your corner, I would like you to take the respective derivative.
Wow.
I can see this.
I could not have seen this.
There's more of you. 1, 2, 3, 4, 5, 6. 7 heads are better than 4, right? You can do it.
Where is that?
Yeah, but now
That's so 20th century.
Maybe if you had a time machine.
Oh, pretty tough to see.
I'm sorry that
Like you would only sleep when your body's like.
What were you between? A time machine?
I took it as like a different dollar. Like you just superpower the time.
So,
No, like endurance.
okay, work together at your group.
That's what I was saying. I was like, 4x squared plus 3x plus fastest marathon.
Could tired also mean like you always have endurance?
Oh, I didn't.
Okay.
Go to the like swim.
Which one are you doing? X squared is 2x.
Yeah.
You jog it up.
And then the 2 and the sine of x, and then like that one. Right? Yeah.
Okay, so my suggestion to you would be
Oh wait, I have my X.
and like when we move towards
That's where I want
like I would probably write that as 3x cubed cosine of x minus x cosine of x. You know what I mean?
Yeah.
But I like that you put all of the parentheses in. That's good. If you don't put the parentheses, I might mistake that for a subtraction.
Well, when I was sitting here, the only one I could see was the red one, so I accidentally did the love of the life. So I
So
guess,
maybe you can come up here and compare answers with Dylan.
yeah, I'm just a lover boy now. What did you get?
2x times 2x plus 3
Yes.
x squared plus
And
1.
then additionally,
Yeah.
Yeah. I'm just like going with something up there, like, you know.
minus
Get over
That's why I have so many.
Time machine.
I already made the point that if you had the time
Do you have an
machine,
inhaler?
you could find it. Like,
And that's great, so like,
I can't go.
Yeah.
I know you. Oh yeah.
Yeah, I'm still cool there. It's still exciting.
I do feel like that's a more feminine thing to like want.
What?
Like a superpower.
It's only
It's like all girls and everything would be nice.
Oh,
I feel like that's a really fun
You look little guys in costume.
Yeah.
So yeah, that could be part of it too.
3 plus.
Like, I never get tired of this.
Where
That's actually probably a big group of guys.
I think that is.
Where
Like,
That's like having a dream and saying,
oh crap.
yeah.
you never know.
Was you were today?
Yeah.
And then there's
Freshman year English, it was me and John and Lyra and then 26 girls. It was deadly.
Plus,
All my cousins have just like all at once.
Bro, we never got it. You get Miss Mike. She's like, she'll go.
I still go in her class.
Oh yeah, I got sights.
Heidi,
You draw birds in English. One of the days, she put up a how to draw a bird tutorial, and we just followed along for she draw
yeah, technically.
Oh yeah, I did it. Yeah, I know. I never.
All right, go ahead and have a seat.
Love that. That's pretty good. That's good.
How would you draw a bird on Max Hammer?
Okay.
I don't know, I don't know where it's
Yeah, me too.
I put my locker in my head. Because all these years of soccer and I
Okay.
But there's always
Okay.
that cool kid that goes to
I need your focus up here. I need your focus up here. My time machine, can you travel back to your seats?
I just really need time travel back in the
Just in a different
Okay.
Oh yeah.
I do want to talk about this green one right here.
That's what I did.
Okay. I want to talk about this green one right here. Is it just a product? No. We have 3x squared, which the derivative would be 6x, plus x cosine of x is the product rule. So we take the derivative of x times cosine plus x times the derivative of cosine. So we do power rule plus we have our product rule. Do we all see that? Do you need to write it down? You don't have to, I'm just saying, do you need to? Okay? Number one, your corner was very similar to where you had a product rule and then just a trig rule, just a simple, straightforward rule. Yeah. Okay, do you notice how I put parentheses around the negative sign of x? If you don't, and you do this, what's it going to look like? It's going to look like subtraction. So please use parentheses. Okay? I'm kind of strange, so I would probably rewrite it like this. I'm a little OCD, but you don't have to. You can leave it with all those parentheses. Okay? All right. If you don't practice this, well, are you going to remember it? No, you're not. You got to practice it to understand it, okay? Also, something like this. Is the power rule going to help us here?
No, but the quotient rule.
The quotient rule will. Would you like to know the quotient rule?
Ferris.
Just multiply.
What? What are you doing?
So just drop your pencils real quick. Drop your pencils. The derivative of f divided by g.
Yeah.
F prime times g minus f times g prime. That's very similar to what we just saw, except there's subtraction, so order will matter. All over g squared. Write it down.
That's what close.
Least of our words.
I feel like it's the most in the Jordani's words because it's gonna read my English.
Okay, now, when I was in high school, a long time ago, the way I remembered the quotient rule was by the same. You don't have to use it, but I know that there's a lot of stuff up there, so if it helps you, go for it. Okay? Low d high minus high d low all over low squared. Okay? What does that mean? Low d high. Denominator times the derivative of the numerator. Low d high minus high numerator d low derivative of the denominator all over low squared. Denominator squared. Hey, did I tell you that you have to use this?
No.
No, but if it helps you, go for it. This is the derivative we're going to take, so please write down the function. And you know what? Just for Brinley, we will rewrite it to be h of x.
You're gonna have to change all the tests now. Everything's gonna be confused. I'm gonna come up every question. Does that are you sure?
Okay, so this is our f function, and this is our g function. So when we take the derivative of a quotient, we take the derivative of the numerator times the original denominator minus, I heard somebody say it, our original numerator times the derivative of our denominator. All over. We keep our original denominator, but now we get to square it. You leave it like that. And here's why I say you can leave it like this. Think to yourself, did you make an algebra mistake on your quiz yesterday? Just think to yourself. Okay. How easy is it going to be for us to make an algebraic mistake going from this to simplify it? Yeah. So let's just, maybe not, and try to get a few more points out of the deal. Okay. When we get to unit 3 and we have to set this equal to 0 and solve, then we'll do all of that algebra. Okay? But for now, it's fine to leave it like this.
I love to do the least amount of work.
Write it down. Okay. Now, could I have given you this problem on yesterday's quiz?
Yes.
Okay, and Max,
Yes.
what would you have done?
Just split it into two different.
So you would have written x minus x to the negative second.
Yes.
Yes?
Yes.
Okay. Which means our derivative would be 1 plus 2x to the negative third.
Yes.
Okay. Or maybe you don't recognize that that can be split up and you think, hey, it's a fraction. I can use the quotient rule. That's fine. Your quotient rule would give you, what's the derivative of our numerator?
3x.
3x squared times our denominator minus our numerator times the derivative of our denominator all over denominator squared. It feels so wrong.
There's so much you can do with that problem.
Okay, so let's talk about that, Courtney. Can you leave it like this? Yes, you can leave it like this. If we simplify, we would have 3x to the fourth minus 2x to the fourth plus 2x all over x to the fourth, which would then simplify to x to the fourth over x to the fourth plus 2 over x cubed. Same thing. We get the same thing. Welcome back. Okay. Now, I can tell you which method that I would probably choose. That doesn't mean that's the method that you choose. Okay, and sometimes it's a matter of what vision do you have when you see it. Some of us aren't going to look at that and think, oh, I can split it apart. And that's fine. Some of us are just going to go straight for the quotient rule. Either way you do it, I have no problem. Okay? All right, last one. Interesting. Interesting. What is the sine of x over cosine? Sine over cosine is tangent. File it away briefly. Take 60 seconds and do the quotient rule for me. Max is going to need to go take the test out in the hall so he can sing for himself. All right, Ethan, rattle off for us what you have.
Cosine x times cosine x minus sine x minus sine x divided by cosine x.
Minus sine x, like sine x minus?
Quantity negative sine x.
Okay. All over?
cosine x upon a squared.
Okay. Now, I've told you that yes, you can leave it like this for now, but let's just go a little bit further with this because I feel like we have some identities that could be useful here. Our numerator. Do you agree that our numerator is the cosine squared of x plus sine squared x? What's cosine squared plus sine squared? Oh. And what's 1 over cosine squared the same as?
1.
What?
No, secant.
Our function was sine of x over cosine of x, which you told me was tangent. Instead of having to do the quotient rule every single time, the derivative of tangent of x is secant squared x. You just proved that. Good job. Oh, we did. Because we did it in general. We did it in terms of x.
Yeah.
The derivative of tangent is secant squared. That's something that you need to remember. Okay? Yeah. I think tomorrow we'll look at cosine of x over sine of x. Did you have a question, Ethan?
No.
Okay. Okay, I don't think we're gonna actually, oh, where'd it go? I thought I had, oh, there's my extra example. No, we're not gonna do it. Let's just talk about it. Overall, what's happening? We have a product, right? We have a product. Here's our first function times our second function. However, when we take the derivative of our first function, we're going to have to do it using the quotient rule. Okay, glad we see it. All right, I am going to post my homework solutions again today. Please check your answers with mine, not the book. Otherwise, you'll have no idea if you're doing it right. Okay?
I was so wet. Yeah. I was gonna walk out.
Now it's
T-shirt.
now it is.